All right, here we go. Wednesday. So you had a worksheet. If you notice, you didn't have any of the ones with you're trying to find the diagonal distance or the longest distance that fits inside a box. We'll have that tonight. So all you had was basically slant height and height. All right, so let's go over this real quick. All right, question number one. The answer is 21.1 centimeters. Now, if you rounded differently, just make sure that your answer is equivalent to mine. Number two, 9.4 meters, 9.4 meters. Question number three. For some reason, I never remember to tell people about question number three, and I do this I've done this like 3 years in a row. So question number three, well, technically, this one doesn't have an answer using the techniques that I did. For those of you that realize that, good for you. For those of you that put the answer was 10.7, I mean, I know why you put 10.7. We'll just go with that. This one's a bit more complicated, and I always forget, and I write notes to myself, and I still don't change it. I'm not sure what's going on there. But anyway, the correct answer is 11.6. If you guys got 11.6, you guys did really well. Because 11.6 is the actual answer. So let's just not worry about number three. Let's go to number four. Number four is 12.7 meters. Number five is 13 feet. I'm doing some rounding here, 13 feet. Number six is 26.9 centimeters. Number seven is 7.94 inches. And number eight is 6.7 meters. 6.7 meters. There you go. Okay. We're going to finish this section on using Pythagorean theorem to find this thing called the slant height and the diagonal distance of a rectangular prism today, and then we'll move on. So on Friday, we're going to have a quiz. The quiz will be on basically all the basically Pythagorean theorem. So I'm just going to give you triangles, and then you're going to have to solve it will just be on Pythagorean theorem. So if you're good on Pythagorean theorem, you're good to go. So even though slant height uses Pythagorean theorem, I'm not going to make it complicated. I'm just going to give you some triangles. You're going to be solving for the hypotenuse, or you'll be solving for one of the legs. So straight up Pythagorean theorem, yes. Obviously, you can use your calculators for this. Okay. So we're going to finish up today. So it's another worksheet can be found on the bottom of the Google Forms. Oh, I forgot to tell you, go ahead and answer question one on the Google Forms for how many you got wrong. All right, so on the bottom of the Google Forms, you'll see the next worksheet. And it's basically a continuation. So a few of the ones that we did for slant height, and then a bunch of the ones that are on the diagonal distance of rectangular prisms. A quick reteach, right? Remember, we have this new concept called slant height. Slant height is the perpendicular distance along a pyramid from its base to its vertex. So it's measured right there, and that would be the shortest distance. You notice we went on one of the corners of the pyramid, it would be a little bit longer, right? You have a little bit longer of a walk. But this is the shortest distance between the base and the vertex. Okay, but remember, we also still have this thing called the height, and the height is the perpendicular distance between the base and the vertex. So that's the basic picture that you get right there, or the relationship between slant height and height. Not too challenging. And then if you notice, we can always connect the two red lines there, and we get a right triangle. And that right triangle is how we calculate both height and slant height. So here's one quick example. The one key feature here is we'll notice we got a height of that pyramid of 10. And if we want to calculate the slant height, well, you need two numbers for Pythagorean theorem. We only have one. And the indicator here is that it's a rectangular square pyramid right here. It's a square pyramid. Therefore, we know that that smaller leg of the right triangle is 3 there. That side right there is 3 because it would be half of 6. And that's only true for a square pyramid. So if it was a true rectangular pyramid or triangular pyramid, we'd have to do some other calculations here in order to figure out that piece. But for all the ones that I will give you, they'll be square pyramids. Okay, so let's see. We got two legs of that right triangle there, 10 and 3. We're missing the hypotenuse. Therefore, we're going to solve for C there. Let's see, 10 squared is 100, 3 squared is 9, 100 plus 9 is 109. To get rid of squaring, we take the square root of both sides. Therefore, C is approximately 10.4. 10.4. Okay, makes sense? All right, so you can do this one. Let's see, calculating the slant height of a square pyramid. Square pyramid. So we have one of the legs is 24. The other leg is not there, but we know the side of that pyramid is 16, and the height goes from the middle, so therefore half of that would be 8. So therefore I've got the two legs now there. I got A and B. I can simply do that calculation there to find the slant height. So 24 squared is a big number. You add that to 64. Take the square root of both sides. And get about 25.3. Make sense? Hopefully this is a quick review for you. So the one difference here is instead of giving you or calculate the slant height, so for instance, if I give you the slant height here, which is 45, how would we solve for B? Okay, so it's still the Pythagorean theorem because it's a right triangle. The only difference is I don't know what B is. So I plug in my numbers right there and simply go through the calculations. Pretty big numbers, not too challenging with a calculator though. 42 squared is 1764 and 45 squared is 2025. On this one, remember, if we're solving for b squared, the first step would be to subtract 1764 from both sides. We get that, and therefore, in order to solve for that, in order to get rid of the square, we take the square root of both sides, and we get about 16. Make sense? Okay. We also did cones as well, too. So there's your picture of cone and relationship between slant height and the height. Remember, the height is the perpendicular distance between the base, which is a circle, and the vertex. And the slant height would be the perpendicular distance on the outside from the base to the vertex. Okay? So if you play connect the dots there, right there, you still get a right triangle. And there would be an indicator of where the slant height would be. So the slant height, once again, is the hypotenuse of that right triangle. Make sense? Okay. So we can use the Pythagorean theorem to solve this. So here's an example right here. We got two legs of 20 and 11. So calculate the slant height, right? That would be our C value. And it's just straight up the Pythagorean theorem once again. 20 squared is 400. That gives me 521. And the square root of both sides is about 22.8. Notice, once again, I'm pretty lazy here. I'm leaving off units here. Well, there are no units listed here. So if we were to put units, it would be 22.8 units. All right, let's do one together. This is good practice for the quiz because remember the quiz is just going to be on Pythagorean theorem. So it looks like we got our two legs. One is the height, one is the radius of the circle. That'd be 121 and 25, which give me 146. Square root of 146 is 12.1. Just make sure you're using the pause button. Don't let me just ramble on quickly through these problems right here. So if you understand what I'm doing, that's great. But if you're having some issues, just hover over the pause button. As I say the step, you hit pause. You think about it. You look at the numbers. You make sure you understand where they come from. If not, rewind. Listen to my explanation again. But just don't hit play and just kind of zone out here because you need to make sure you understand where all the numbers come from and the logic behind the calculations. Make sense? Okay. I'll try not to say make sense again. Ooh, look at this one. Hey, we're given the radius and we're given the slant height. So what we're missing here is the height. In other words, the A or the B value, depending upon what you want to name A or B. Remember, A or B are the two legs. C is the hypotenuse. Okay, so this one's still not too bad. We're just basically using Pythagorean theorem. 6 squared is 36, 11 squared is 121. And on this particular one, we're going to do a little bit of algebra. Subtract 36 from both sides. 121 minus 36 is 85. Take the square root of 85. Let's see, that's going to be a little bit bigger than 9. And it's about 9.1, but we'll just approximate that to 9. Okay? All right. So let's get on to the thing that's going to be added to tonight's homework. So all that will be, I'll just give you a couple of those tonight for homework. But we're going to do this diagonal distance. And this is an application. And basically, it's what's the longest object, imagine a broomstick. What's the largest broomstick that fits inside this box? Well, it wouldn't fit on the bottom. It wouldn't even fit diagonally on the bottom. It would fit diagonally from the top to the bottom. Okay, from the upper, let's say, left to the lower right, or from the upper right to the lower left, either one of those. That would be the longest broomstick that you could fit inside this box. And remember what I said yesterday, or the last class, of how you do this calculation. We basically make a right triangle. So if I extend that particular dimension right there and then connect the two segments right there, that's the triangle that I'm going to be solving for. And I'm going to be solving for the hypotenuse there. So here's how this works in an actual example here is I'll give you a rectangular prism, right? It's got 3, 4, and 3 as its dimensions. Step number 1. So there are some steps, and I'm not going to have you write down the steps. Step number 1 is we find the diagonal on the bottom, okay? Notice I'm just looking at that triangle now on the bottom. Ignore the rest of the box. So it's got side lengths of 3 and 4. We solve for the hypotenuse. 3 squared is 9, 4 squared is 16, 9 and 16 is 25, and the square root of 25 is 5. So that dotted line right there is 5. All right, that's part of the triangle that I need to set up for my final answer. Remember, I'm trying to solve for that dark red line right there. So I needed that dotted line there as part of my triangle. So now the triangle I'm looking for has legs of 3 and 5, and the dark red is the hypotenuse. In other words, that's the triangle that I'm solving for. So 3, 5, and unknown, right? So 3, 5, and C. Square everything. That's 9 plus 25, which is 34. And the square root of 34 is a little bit less than 6. It's about 5.9. Okay? I'll round that to 6. So the longest broomstick that I can fit inside this box is about 6. And you're like, well, wouldn't it be smarter to write 5.9? Yeah, you're agreed. But you understand the logic of where I got that 6 from. Okay? All right. For those of you who know what you're doing, go ahead and pause the video, get to an answer, and then answer the next question on Google Forms. For those of you that need a little hint, well, just play until you, follow along and play until you've got it, and then hit the pause and finish it. Okay? Try not to listen to the whole darn thing. Try to get this one all by yourself. Okay, so to find the longest broomstick that will fit inside this box, first thing we do is we draw a diagonal line along the bottom, right? So that's a triangle with side lengths of 10 and 8, or legs 10 and 8. It's a right triangle. And we solve for the hypotenuse. 10 squared is 100, 8 squared is 64. That gives me 164. And the square root of 164 is about 13. So that dotted line right there is about 13. Now remember, the broomstick would fit like that. So now I have the triangle of 10, 13, and unknown length, right? The red part. That's what I'm going to be solving for. Okay? So let's see. 10 squared is 100. 13 squared is 169. It gives me 269. And the square root of 269 is about 16, right? So did you guys get 16? If so, then you know what you're doing. And that means you can do the worksheet. So if there's any questions, hit me up on email. Remember, the quiz is just going to be on the Pythagorean theorem. So I'm just going to ask you, I don't know, maybe 6 questions on the Pythagorean theorem. So 6 triangles, finding either the hypotenuse or the legs. Okay? So I'll see you guys on Friday. And there'll be 2 links. There'll be one for the quiz and then one for the class. Okay, see you guys on Friday.